So in continuation with respect to the previous slide, the DC servo motor, it is used in the servo control system to produce precise control of position, speed and torque using a feedback mechanism. It operates using direct current supply and is commonly used in automatic control system. So in the construction of the DC servo motor, there will be a stator, there will be a rotor, commutator and brushes, there will be a feedback device and controller. So in the stator, it is going to produce magnetic field. In the rotor, rotating part where current flows in the rotor. The commutator and brushes supply current to the armature. The feedback device, it will be having an encoder or potentiometer for position feedback. The controller controls the motor operation. So the controller sends a control signal to the DC motor. So the motor rotates according to the input signal given to the DC servo motor. There will be a feedback device. It is going to measure the position and speed of the motor. If there is any error between the desired and the actual position, the controller adjusts the motor movements. So as it's a closed loop system, high accuracy and precise control, it is accepted. The characteristics of the servo motor, it is the overall response is fast, high torques at low speeds, it is get time. The speed control overall of the DC motor, of the servo motor, it is good. Overall accuracy, it is high. The disadvantages of the system is it needs regular maintenance as I got brushes and commutator. Higher cost compared to the normal DC motor. The brushes wear out as the time progresses. So advantages is it is simple control system. There will be a quick response to the control signals what we use. The overall efficiency of the servo motor, it is good. High starting torque, it is available. The various applications of DC motors are in the robotics, CNC machine, antenna positioning systems, radar systems, precision instruments, industrial automation. Like this, we have got various type of applications. So troubleshooting of the drive system, we have to identify the root cause for the trouble. So some of the common problems what we identified is motor is not starting, motor gets overheated. There will be noise or vibrations when we use the drive system. There will be speed fluctuations of the drive system. There will be frequent tripping of the protection devices. There will be reduced motor performance. Identifying the root cause of the motor is to check the power supply. We have to ensure that the required voltage and current supply happens to the motor so that the failure doesn't happen. Check for the blown fuses or tripped circuit breakers. Inspect electrical connections, like look for loose wires, damaged cables or poor connections. Check drive controller, verify driving settings and parameters. Check if the controller is functioning properly. Inspect motor condition. So we have to check the windings whether it has got damaged or what. Looks for overheating or burning smell. Check the mechanical load. Ensure that there is no mechanical blockage. Check alignment of shaft and coupling. Check sensors and feedback device. Inspect encoders, limit switches and sensors for faults. Check solid state switches, means it may be transistors, SCR and MOSFETs, they are working correctly. So by using these 7 points, we'll be able to check the root cause for the problems in the motor. So examples for root cause identification is already all these points I have discussed. So importance of root cause identification is prevents repeated failures, improves overall system reliability, maintenance cost is reduced by finding out the root cause, equipment life increases if we find out the root cause for failure. Remedies for the corrective actions. Some common problems and suggested remedies are: problem, possible cause and remedy. Motor not starting, there will be no power supply. Check for power supply or fuse or circuit breaker, it is proper. If the motor is overheated, so possible is it is overloaded or poor ventilation. Remedies: reduce load and improve cooling by adding some attachment or some heat sinks so that it is going to remove the heat at the workplace, or to provide enough ventilation space so that the overall heat generated it is going to move out. speed fluctuation, fault controller or drive settings. Adjust or repair the drive control, that is the remedy. So noise or vibration, worn bearings or misalignment of the parts. So replace the bearing and align with the shaft. Frequent tripping means overcurrent or short circuit. Check wiring and remove the fault. If there is loose connection, then there will be poor electrical contact. Tighten or replace the connection, that is the remedy. So motor winding damage means there will be insulation failure, that is a possible cause. Remedies: repair or rewind the motors. Mechanical blockage, load jam or obstruction. Remove obstruction and check the load, so that you are going to have a remedy. So these are all the general remedies for the drive system faults. So what are the steps to be followed in troubleshooting? Identify the problem, check the power supply, inspect the wiring and connection, check the control system, test individual component, isolate the fault, repair or replace the fault components, test the system,